Alright, so now it should be streaming at Alright, it should be streaming at full quality. Let's hope it does. If it's not, then I will be told it's not. Okay, let's get this thing set up correctly. That should be big enough for people to still read it, but I can also read it. Alright, hopefully this is working. Let me set up everything else in the meantime. Let's not listen to the let's not listen to my own stream, because that should not be very nice for everyone listening. Hello, Pigard. I'm talking right now. Hopefully it's not too loud, because I had to change some settings, and hopefully the background stuff isn't too loud either. If it is, just let me know. And hopefully, let's find out. I did a test recording earlier. Let's find out if it's recording it without the background audio, because I don't want to get 13 copyright claims again. Nope. Cool. And you gotta hear me singing for there a bit. Hello, Zeke. Alright. So everything should be good. I'm just gonna keep going. I have to figure out where I left off, though, from yesterday. Because I got a lot done yesterday. I'm not sure where I stopped. I think it was right before the, right before I started implementing the generation algorithm. So, let's see. I left a bunch of to-dos. Just read them all. Get rid of this and do something more efficient. That's definitely needed. Add fields to keep track of pieces for instruction generation. Okay, so this will be done later. Increase dimensions, move structure around if necessary. Alright, so let me do that first. So all this is doing here is just making sure the brick can actually be placed in a certain structure. Oh my gosh, I'm so sorry. Asthma's acting up right now. So this part here just goes through and checks to see if a brick can be placed in its certain location. And if it can, it just places it there. But what I'm not checking right now is, for example, if the brick is all the way in one corner, but there's plenty of room, so I can just move the entire structure over and then still place the brick there. So that's what I need to do now. Alright, give me 1 second. I need to use my inhaler. This is getting bad. Alright, that should start kicking in over the next hour or so. Okay. Cool. Alright, now I can actually continue working. Hopefully I don't have to stop streaming early in a coughing fit. So, should I do the generation algorithm first, or should I... This is necessary, so let me do this first. Making sure that you can just move the structure over if it wants to place a brick there. Okay, so what we're going to do... So if this... If this isn't true, then we're going to throw an exception, but we're not going to throw it just yet. We want to first make sure that all the pieces can be moved over in that case. So that's literally just determining which of these is firing, or if there's more than one that's firing. So let's just go through each one. Bound 0, 0. Greater than 0, or in this case we want less than 0. So less than 0, shift, structure. So this is the x coordinate if it's less than 0, so we're going to shift it right. If it bounds 0, 1, so less than 0, shift structure, structure, shift it up. If, I'm just going to copy this. If that, so if it's greater than or equal to the dimensions, or if it's greater than or equal to the dimensions, then this one we're going to shift it left. Shift, sure, left. So this is going to be horrendously inefficient, but really the only way I can think of doing this at the moment is shifting each brick over and then doing all these checks again. Or really, no, I just need to check if the left bound can... yeah, I need to check the left bound, so that should save a little time. But one thing I do have to take into account too is how far I need to shift it. Because if I need to shift it right, I need to make sure that the rightmost bounds don't end up outside of the region either. Okay, so let's just do that. So for brick in, how are we storing this? This the pieces. I don't know why I'm doing this dot in all these. Let's just get rid of this, because I don't really need to. For each piece in pieces, I need to see if I can shift it right. Actually, first, let's do the check to see if it can actually, if it doesn't collide with another brick first. And because it's going to be doing this anyway, just put it out here. So first it checks if the brick, when you're trying to place it, it's going to collide with any other brick, which obviously you can't have in Legos. And then it checks if it's actually going to be within the bounds or not. So for each brick in pieces, so I first have to figure out how much I need to shift it by. So the bounds 0, 0. So let's just say it's at -2 for the bound because of the direction. Then that means I have to shift over 2 places. So it's going to be the 0 minus the bounds. Right? So it's whatever going to be the negative x value of the bounds. Let's just go with this and see if it works. Okay, actually, let's go to page.net. So let's just say it's going to, the grid is like this. I'm a great drawer. And I want to put the break here. Now I can't do that. So it has to shift everything over by 1 because its lower bound is -1, 0. And if I put it over 2, then it'll be at -2, 0. So yeah, I just need to do 0 minus whatever the x coordinate is. If piece dot get bounds so if the bounds of it, if the bounds of this piece can handle getting shifted over. So I need to make sure that this is less than the the dimensions along the x-axis. Oops, this needs not. Now I'm going to be calling get bound several times. Let's actually make a field here. Public, and I want this to be an int array. Bounds equals null if bounds equals null, or if it doesn't equal null, just return bounds. And then down here we're going to return bounds. And for all these, instead of doing this, this is just going to be bounds equals. Of course, that also means we need to put a break in each of these, so let's do that. Break. I'm just going to return the bounds. So now it's never going to return null. So that actually solves 2 problems there. Okay, so let's come back down here. Where was I? Here we go. So we get the bounds, and then add the shift to that bound and make sure it's still inside of it. If it is, then we're good to go. If it's not, then we throw an exception here. So if it's greater than or equal to the dimensions, we're going to say it's out of bounds. Otherwise, if it can do it, then what we're going to do is we're actually just going to do it. So brick, we're going to do piece dot move 1, 0, 0, or no, shift. And I'm going to implement this method real quick. Come up here, and we're going to put it here. Internal don't know what internal means, but it's okay for now. Shift V1, V2. No, so this is going to be X offset, Y offset, and Z offset. And we're going to find the position. So this dot position 0. Its X position equals, or plus equals offset dot X position, or it's Y position actually, plus equals Y offset plus equals Z offset, which I'm going to set to 0 because I don't think I'll ever use a shift in the Z direction. So we're going to, and I'm also going to rename this method because it doesn't really make sense as a move. It's really shifting. So then it's shifted it, then we can add the brick. Add brick, brick, and we should be able to, it should be the same position and direction because everything is shifted over so it can be in that position. Oh wait, no, that's not how that works. Shoot. Alright. So instead of position, we're going to do 0 plus shift, which ideally puts it at 0, so I can just say 0. And then position 1, position 2. So that should fix that, and I'm going to go ahead and copy this for each one. This one is the same thing except all these are 1s. This is shift, position 0. This puts this one at 0. Oh, you know what? Crap. I can't add the brick here because it'll be adding it like 3 times. So the add brick actually needs to go down here. Yeah, so the add brick needs to go after the entire thing. This throw exception here is no longer necessary. Not all code paths return a value. Return null. How does that fix the problem? Oh, because it falls through. So this needs to be a return this, actually. Yeah, there we go. So let's see. So we're shifting the piece over. If it's top Y bound is going to get out of the grid, then we can say hey, we can't place it there. But if it can do that, then we do want to shift it. So now we have to do the same logic, but moving it backwards instead. So if it's top bound is outside, so if the brick we're wanting to do is like something like this, and its top bound is actually outside of it this time, like this, then we need to shift it back this way. So here, on this 4x4 grid, this would be position 4. 1, 2, 3 is where we are here. So what we're going to do is just subtract wherever it is or no, we want to subtract whatever the dimension is by where it is. So there's 4. The dimension is 4. And its position equals 4. So this should equal -1. So we need to subtract 1 from whatever this is. Perfect. Hello, Porku. So we shift this over. So this is the shift, and then we just need to make sure that this is the opposite condition now. That if the other one after the shift, and this is going to be a negative shift intrinsically. It should be. We'll do some tests after it. So this is going to be a negative shift, so I don't need to change the sign here, but I do need to change this to the first coordinate. And then since it should be a negative shift, I don't have to deal with that. Come down here, do the same thing for the y's. Y, shift. Oh, shoot. Now, here's the issue. Now, all these shifts are different, so I have to account for that when I'm actually adding the brick. So I think I just need to update the position, or I'll just do this. Int new position, or no, int array. New position equals new int. If I do dot position, or if I just do equals position, then that's going to modify the original position as well. I think because that's how object-oriented programming works. So dot copy, dot clone. There. Now hopefully this is the C# way to do this. So new position equals just clone position. Now ideally what will happen is the brick will get shifted over, but there shouldn't ever be a scenario when multiple, like for example, if this if condition fires and then this one fires as well, because it shouldn't move it over enough for the top bound to go out again, because it's like if we put it over here, it should never shift it over enough where we have to worry about it getting over here and firing another condition, just making it go an infinite loop. So I don't have to worry about that, ideally. If once we actually test it and that becomes an issue, we will address it when the time comes. So let's just change this now to new position. We have to go through each of these and update the position. So new position, it's x plus equals shift. Down here, new position, it's y plus equals shift. New position, this one is also an x1. And new position plus equals shift. Oops. 1. So now, if we try to place a brick down, let me first do this throw not implemented exception. cannot be used like a method. Oh, this needs new. So let's test this out real quick. So I already have some structures here. Let's make it a 4x4x4 structure for testing purposes, or 5. One of the bricks is going to be, there's going to be 2 3x2 bricks. Oop, no, why is it in zoom mode? Let's just do this out. So I'm going to set it up like this for the test. So I'm going to have 5 columns. And I'm going to put a brick here. Oh wait, it's 3x2, isn't it? One of the bricks is going here. One of the bricks will be attached to it here, on top of it. And then the other one I'm going to attempt to put here, under it. But when I do that, it should not throw an exception because it's out of bounds, but actually move it over. Move the entire structure over. So I'm going to have a... Thank you, I'm very good at drawing, aren't I? So I'm going to have a 3x1 brick as well. So the first Lego is going to go where this is 0, 1, 2, 0, 1, 2. So it's going to go at 1, 1. Oh, it's already there. Second one's going to get 0, 2. 0, 2, and this is going to be on top of it. And the third one is going to go at -1, 4. No, -1, 0, 1, 2, 3. -1, 3. And it should handle that just fine. And then let's just look at pieces, all the pieces and where they're located after I do that. Brick piece in structure pieces. We will do... Is this running in a Unity? Yep. So in this case, debug.log instead of console write line. And we're going to log the pieces dot bounds, or get bounds. And now that I see that, this should be a private field up here. So ideally, if we run this, oh wait, it's not going to actually, let's just run it real quick. If we look down in the console, and it says out of bounds. Crap. So, well then. So let's see why I did that. So I tried to put it here, and it said it fired this at on line 17. So yeah, it'll be the last one that fired that. So I put it, I'm trying to put the brick here. And I can't actually put the brick there, but I want to shift the structure over this way when I try to do that, because it should still have room here to shift it. But it's saying that when we shift it, it can't actually shift that way. I'm not sure why. So bound 0, 0 of the brick should be this one, and that's at position -1, 3. So 0 minus 1, we should get a positive shift to the right of 1. So if piece get bounds for each of the pieces, if it's upmost one, plus the shift, is greater than the dimensions of it, or equal to it. It wouldn't be though, it'd be at 4. So this is what I'm going to do. I'm going to do debug.log the shift format shift. And I'm also going to log the log each piece's new x bounds if I need to. So debug.log format new second bound x. And that's going to be, thank you Porco, see you later, thanks for coming. So this is going to be new second bound, and then they get the bound plus the shift, and we're just going to see what happens when I run this. And it says shift is 1, like we expected. New second bound is x is 5. Why does it think the x is 5? It shouldn't do that. It does that on the first brick it checks, which the first brick I placed is the blue brick on this diagram at least. Oh, I know what's going on here. I know exactly what's going on. So if we look at get bounds real quick, we are adding the dimension of the brick, when what we should be doing is we should be adding 1 minus the dimension of the brick, because this, we're not including, I forgot to include this bit. So if this is the origin of it, and it has 3, so it's going to do 1, 2, 3 instead of only 2. So we need to count for that real quick. Let's do that. Minus 1, minus 1. This dimension's minus the negative 1 is plus 1. Minus negative 1 is plus 1. Plus 1. Plus this dimension, so minus 1. Minus 1. Plus 1. So, alright, let's see if now it works. Come over here. We get, after a little bit, I don't know if it's compiling or it's just taking a while. Alright, I think it's just taking a while, because it usually doesn't take this long. Hello? Unity. Well, that's a little frustrating, to say the least. Okay, I'm just gonna close the window. Maybe not. Task Manager. Close the Unity editor. Reopen Unity. Gosh. Alright, I'm praying that that wasn't my code that caused that. It was just the Unity glitching out a little bit. So if I run this again. Alright, seems to be my code. Alright. Dang it. Let's find out where the issue is then. Well, I'm adding the brick, and why am I adding the brick here? Because it's just running this method again when it really doesn't need to. I already know that it doesn't overlap with any bricks. So I should just do the manual adding of the brick instead of... So if I do, alright, if I shut down, oh, I didn't change my screen. If I shut down Unity again, yep, you just saw that as you sent that message, Zeke. Alright, let's close down Unity again, and open it again. Third time's the charm. So immediately I see that it says the result of comparing value type Unity engine rect with null is always false. Why is it always false? Oh. Here's something. I think that was just a random warning that it didn't check all the way. So now, if we look at the test, it did shift it properly, but it's not printing the arrays properly. Dang it. Okay. Let's just go ahead and fix that real quick. Log format. Bounds. 0, 1. Hello, Mark Sam. How you doing? Int array bounds piece get bounds 0, 0. So I'm curious, whoever's here, how do you feel about daylight savings time? Because that's apparently, I found out today that you guys are changing your clocks tomorrow. I live in Arizona, so luckily I don't have to change my clocks or anything or worry about it. I didn't realize it was tomorrow though. Figured says terrible. Yeah, I imagine so. Because you just have to... It's just a pain in the butt, ain't it? Because you have to go through and change all your clocks. And your body has to get used to your new schedule. And there's just... I personally think it's pointless. It might have been helpful, like, 100 years ago. When did it start? I have no idea. But it probably was helpful when it started, but nowadays, it's not, in my opinion, it's not that helpful overall. But you guys are welcome to argue with me on that one. So, I should be logging the bounds for each piece. So if I come over to Unity, it says that, well, that ain't right. So it's a good thing that some devices automatically change it for you. Most modern things should. The only thing, like, for me especially, I still use a traditional alarm clock and a second one to wake up in the morning. So having to change those, it took me half an hour to figure out how to change it the first time. I really don't want to go through that again. So one thing we do see here, oh, yeah, I know exactly what the issue is here. So when I shift it, that means I need to recalculate the bounds. So on a shift, I'm going to do What do you do this? But do calculate bounds. Alright, and all of this here is going to be replaced in, it's going to be public void calculate bounds. Whoa. There we go. Calculate bounds. Else, calculate the bounds and return them. That should, excuse me, that should help. So I realized again that you cannot see what I just did in Visual Studio because I forgot to change it, but I'm going to show you Unity anyway right now. So the two that needed to be shifted over did actually get shifted over, but the piece I just put down did not, so I need to do that one as well. So if I come over here, when we add a brick, specifically this brick, we're going to do brick dot shift, or no, brick dot calculate bounds. What module am I making? I am making a Lego module. So the general gist of the module is that there's going to be around 10 pieces that you're going to have to gather. So what that means is I would imagine when I'm done with this, the most effective way to actually expert for this is that actually have Legos in front of you. So you would have the Legos, and you would build the structure, but the instructions for the structure are on the module itself, and each page of the instruction manual on the module only has 2 pieces on it. So you have to figure out how each 2 pieces are connected, and then eventually, once you get through all the pages of the instruction manual, you'll get to a single structure. But overall, on each page, you don't know which orientation that page is facing, because it's going to be a top-down view of each connection. You don't know which orientation that is, and you don't know, and you have to keep track of the orientation of that, which is found in the actual manual for the mod. You also have to keep track of the orientation of the full structure, because when you go to submit your answer, it's going to be you're submitting a top-down view of what colors you see, or a bottom-up view of what colors you see. So, if all goes well, that's what I'm doing. If not, then all this work will not be for nothing, because I'm sure I can use the Lego library for something else. So now I come down here in Unity. Seems complicated. Yeah, it's a little complicated to explain, but it'll be much easier to actually solve. So I run this. It doesn't seem to be updating the bounds of the new brick that I just put in. And I'm not sure why, because it's telling it to calculate the bounds again. What if I calculate the bounds before I put it in there? Shouldn't change anything. Yeah, doesn't change anything. Oh, no. Dang it. I have to shift it first. Shift. Okay, so I actually have to shift it as well. Oh no, I'm already having the new position, but I'm not using it for anything. Brick update position, or update location, new position, and we're going to do direction. Just whatever the direction is. So hopefully, now when I test this, it should actually print the correct bounds for that piece. Why can't I figure this out? So when it updates the location. Oh, when it updates the location, it doesn't calculate the bounds either. Ah, dang it. Alright, now it should work. What is this, like the 16th time? 17th time to charm, right? There we go. Yay! Okay. Now that it shifts it... Oh, wait a second. I just realized I forgot to account for shifts in the Z axis. So let's do that real quick. But that one's actually quite easy. You only have to consider when the Z is less than 0. Then I just shift it offwards. So in this case, I'm actually going to do this. I'm going to do true here. And this one we're going to do true bool allow height adjustments equals, I'm going to set that to true actually. So this is in the future if I want to use this library for anything else, I can disable allowing it to change the height. So we're going to do, this can be private, so private bool allow height allow or height adjustments allowed equals true. Well, let's just not define it yet, and then we can initialize it down here. Height adjustments allowed equals allow height adjustments. Perfect. So now if I come down here to add brick, I'm going to see if and bounds for... So I realize now that the bounds doesn't actually include the Z value, but that shouldn't be an issue. No, that's not an issue because I only need to look at position because Lego bricks, at least in this model, can only be one like unit tall, I guess, whatever you call that. So if we're going to be looking at position 2 is greater than or equal to 0. So if it's not greater than or equal to 0, we can come down here, say if position 2 is less than 0. First we want to check if height adjustment is allowed, and if it is not, then we're just going to say, hey, you can't put a brick there. But in most cases, height adjustments will be allowed. So what we'll do is shift everything up 1. So the first thing we need to do is make sure that the so for each piece we're going to look at the Y position of the piece, or the Z position of the piece, and if it's greater than or equal to the dimensions of the actual structure, then we're not going to throw an exception. All we're going to do is just increase the dimensions. 2 plus plus plus, or this is plus 1. Then we will simply just piece dot shift 0, 0, 1. Now hopefully the shift method actually accounts for z. Cool, it does. And it recalculates the bounds. It doesn't really need to recalculate the bounds in this case. And whatever, it's not that bad. So I'll shift it upwards, then it'll update. Oh, I also need to update the location of the brick. New position 1 plus equals, or no, new position 2 plus plus. Then we need to update the location with the new position. One thing that we also have to do that I completely forgot about is that so the structure has a has an array of brick layers. So I'll also have to adjust that. I wonder if there's a different memory model or data model. Oh my gosh, I forgot to change it again. Dang it. Thank you for pointing that out, Mark Sam. I keep forgetting to change the stupid scene. Oops. Yeah, this isn't cheap checkout, Mark Sam. So, what we're going to be doing here is we need to make sure that when we shift it up or down, it's only going to be when we shift up in the z direction. Oh, wait a second. Shoot. I forgot about something. And position 2 and position 2 is less than dimensions 2. So we're going to come down here. If position 2 is greater than or equal to this dimensions 2. First, we're going to check if we can actually do a height adjustment. And we're going to do dimensions 2 equals position 2 minus 1. Which will just make it however tall it needs to be. And because I don't imagine us having to do very much, how do I say this? To do very much shifting in the y direction. For now, I'm just going to, whenever we shift in the y direction, I'm just going to actually recalculate all the layers. So we come down here. Layers equals new list brick, whatever. And we're going to do for each brick piece in pieces, layers, and whatever layer that piece position 2 is, I'm going to just add it to that layer. Perfect. Oh, shoot. Oh, dang it. I only want to do this if it's a white shift. Dang it. So how do I do that? I'll just do this. Recalculate layers equals true. So if you calculate layers, do this. Otherwise, just do this. New position 2. Add break. So I also need to take this. Do bool this equals false. So that should account for any shifts we need to do just from placing a piece down. So now what we need to do is we can actually get into the nitty-gritty of the algorithm to actually generate this structure. Yay! But before I do that, excuse me for a minute or two, I'm going to go get a glass of water. So I will be right back. Alright, I'm back. Alright. Now that I've gotten a drink, we can start making the structure generator. So let me think about this. Hi, RSK, or Risk, or how do you pronounce your name? Risk 700 or RSK 700? Oh, good. Judging from the capitalization, I'm assuming it's Risk, but I don't know. So currently I have it so it's more heavily weighted, as you like. Okay, I'm going to say Risk then. So it's currently weighted more to have a higher chance of getting 3x2 pieces. Then 3x1s and 4x1s are equally weighted. Then 4x2s and 2x2s. Rusk. Okay, there we go. Ruzusk. Alright. That's an idea. Because yesterday I actually made a notepad document. Here we go. So this is the algorithm I'm going to be implementing. Starting now. Probably not all right now. So first thing is need to choose the 10 random breaks. So that shouldn't be hard enough, or shouldn't be hard enough. Shouldn't be difficult. Shouldn't be that difficult. There we go. I love popcorn, or picarara. I don't speak Cyrillic, so I'm going to assume that also means popcorn. So what to do. First, go down here. Choose 10 random bricks. So, I'm going to do int p public int. It's pronounced Ruskaya. Pikakakara. This is C#. Yes, this is C#. I am Ruck. It's pronounced Ruskaya. But okay. Pikaka. I agree with Pigard. I'm pretty sure it's Pikakara from what I see there. So, pieces. So we're going to do public int pieces. And here we'll just set pieces to pieces. We're just going to have a default of 10 pieces because from when I actually tested this algorithm manually, 10 pieces seem to work best. Ah! Sorry for that. I just dropped my Legos. I have a thing of Legos on my desk right now. So pieces equals pieces. So we're going to take 10 random pieces. So first we're going to build a list of options, I guess. List, should this be an int? Yeah, let's just make it an int. Piece options equals new list int. Yeah. For each int option in piece types, cannot convert type int to int. For int option in piece types. What? That doesn't make sense. That makes no sense whatsoever. What should do a var for now? Oh, I got ping. What about his? What about my what? How would you rate your programmer skills? Oh. On a scale of 1 to 10? 7, 8. I know a lot. I know a lot about many different languages, but I don't know a lot of particulars, like how to use Unity. If you want to know that, then someone like Ash or someone would be better. But like I know a lot about how the languages work and how they function, and a lot of nitty-gritty of just the general stuff about a lot of languages, but I don't know a lot about the particulars of a bunch of languages. That's why I'd say like 7 or something. Hopefully that helps. If yours is negative a billion, mine has to be negative octillion. Oh, Maxime. It's not that bad. You need a jagged array, not a two-dimensional array, to have an int array. Yes, I do. Which, yeah. I'm not sure what's going to happen if I do index and option here. Because I'm not sure what it's actually doing here. I've never done this before. Is it going to go like 5 through each one? Well, let's stop theorizing. Let's actually try it. Let's just, for example, do debug.log option for now, and just see what these are. So I don't need this anymore. But instead of deleting, I'm just going to comment it out for a minute. We're going to do structure generator. SG equals new structure generator. SG.generate. And if I run this, oh, it does go through each and every one. Shoot. Yep. So, so I do need a jagged 2D array. So let's do that. Oh, dang it. Now I have to do this for each one. That's alright, though. Why is it going crazy now? That's why. Does that mean I don't need these anymore? No, I still do. So, now I can do this. Int. I had insert mode on for a minute there. So option 0 for int I equals 0, I is less than option 0, I plus plus. So, oh wait, this isn't going to work. This should be a normal for loop as well. For int I equals 0, I is less than piece types dot, is it length? That is length. I plus plus. Come down here. Equals piece types I. And this is for J. I'm going to do piece options dot add whatever I is. So in this case, I don't actually need to make this separate data value here. Variable. So this should make a list of all the pieces according to their weights. So I just need to choose a random one from that many times. And I also have to assign a color to that specific piece. I just thought about that. Okay. So this is what I'm going to do. So there's always going to be 10 pieces. So do you guys think, let's do this. Do you guys think that it would be better to have 10 pieces of 10 different colors, or 10 pieces where you can have shared colors as long as the colors are different sized pieces? I'm kind of leaning towards the second right now because I think that would make the module a little harder. How would I implement that though? Because I need to keep track of which ones have which colors already. Huh. Okay, so this is what I'm going to do. I'm going to, for now, I'm going to do or each piece has its own color. Yeah, that's what I'm thinking too, Zeke. It'd be a bit tough to implement that right now. So what I'm going to do, I'm going to just have it so the color is unique for each one right now, and then I'll go back and change that later. Color is a non-knowable type. Perfect. Absolutely perfect. But that's fine. I can just do color equals color.red. Must be a compile time constant. Why do you do this to me? Red. Brick color is color.red. I'll just make a note for myself here. To do make colors not unique or unique for each piece size. So for now, I'm just going to have a public. I just want. Actually, this should be private. Private color array equal color options. Let's do color array. So we do red, blue, yellow, green, orange. Is there seriously not an orange option on here? That's a little annoying. So let's make orange. Do color. Full RGB. So orange in RGB, if I'm not mistaken, is 1, 1/2, 1/2. Right? If you define brick color as color, you can have it as null. Yeah, if you put a question mark there, you can have it as null. But when I actually go to do operations with it later, I can't use the methods inside of color because it can be nulled. So instead of that, I'm just going to have it default to a certain color and then change the color of it later. Not. Oh. Alright, I need to look up a RGB color picker real quick. Color picker. So if we do RGB, 255, 127, 127. Well, that's not orange. What is orange? Is that not what I wrote? Is that orange? That is orange. Red, blue. Red and blue make cyan. Oh, that makes perfect sense why that's orange. Yep. Perfect. Thank you, Zeke. So we have red, blue, yellow, green, orange. Let's do black, white. Come on. Color. What other colors do you have an option of? How many colors do we have? 1, 2, 3, 4, 5, 6, 7. Cyan, yellow, magenta. Did I say RBG? Oops. We'll do clear. Oh, I didn't know that was a constant. That's cool. We'll do gray dot magenta and color dot cyan. All right, there's our 10 colors for now. I have no idea if the stream's still going because on my thing when I'm looking at it, it just cut out for a sec there. So hopefully it's still going. So we're gonna do. We have all of our color options, and for each piece option, we're gonna just assign it whatever the next color is. Still good. Cool. Thank you. Piece. Hello. Flo is. Oh gosh, why do all you people that are coming new have these so difficult to pronounce names? Flo's TV? Flo's TV? Let's go with Flo's TV. Hi, Flo's TV. Pieces. Flo's TV. Yeah. Alright. Flo's TV. I'm sorry I'm making fun of your name, but I don't know how to pronounce it. To be fair, I don't know how to pronounce a lot of things. So, don't feel too offended if you feel offended at all. So, we're going to do random dot range. Hello. It's ambiguous between Unity system random and system random. Okay, am I still using system? If not, then I can get rid of it, right? Oh gosh, apparently I am. Using system.exception. How do I get just the exceptions without the random? Runtime? They in runtime? No. I bet it's just base. What are you coding? I'm coding a mod for the game Keep Talking Nobody Explodes that is based all around Legos. And the main goal is to make a module where it randomly creates a Lego structure, which is what I'm programming right now, is the library to actually handle the Lego stuff. So in this case we have to do Unity engine.random because there's ambiguity. Random between 0 and piece options dot size. Is it dot length as well? Thank you, Space Sebi. How do you get the length of a list in C#? Dot count. There we go. So I was going to choose a random one. Thank you. So piece types. So we're going to do this. I need a list of pieces as well. Public. A list brick. Name. Piece count. Pieces. And we're going to do pieces equals new list brick. And then we can come down here and say pieces dot add, and we're going to do a new brick. So item. So first we have to do, I forget how it's defined, dimensions. So it's width and it's depth. Depth. Yeah, I can't even pronounce that word. So we're going to do piece types, whatever this, so we're going to do this piece num, piece num, piece options, piece types, piece num, and we're going to do the first value, which is the second value, piece types, piece num, and third value, which is the second value. So that makes a new brick with those dimensions, and I also have to tell it the color you need to be. So if I come up here, okay, this is what I do. Color, color. The color equals color. So we're going to do color.red. Color.red. And I also want to implement this one and this one without color, like without requiring colors. Color. Dimensions, so we're going to do dimensions. So we have the option of doing, specifying the width and depth, and color, dimensions, and dimensions and color, or just none of that and default everything. Perfect. So now if I come down here, pieces, add new brick, and in the brick I have to specify what color I want, so I'm going to do color options, and the piece count that we're on. So now each piece should have a random color. Well, not random, it's going to have a deterministic color, but it's going to have a unique color. And we're going to have 10 random pieces. So just to make sure it's doing this properly, I'm going to do a for each brick piece in pieces. I'm just going to do some simple logging to figure out what pieces we have. So brick color, we're first going to do that. And brick dimensions. 1, 2. This will be piece.color, or brick color, piece.dimensions. Except I'm probably going to have to do dimension 0 and dimensions 1. What the heck does a color look like when you print it out? Let's find out. So now if I come over to Unity and run this, brick color, oh, it actually says what color it is, perfect. So it should have 10 of these things, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, perfect. And we should see a lot of 3 2s. We have 2 3 2s. So that either means my algorithm sucks, or we just got really unlucky. We see 1 3 2, 2 3 2s. 3 2 3 2 3 2 3 2 3 2 3 2. Yeah, we just got unlucky. Sorry. Alright. So we just got unlucky, but most of these should be 3 2 pieces. So now we can hop over to Visual Studio and notably remember to swap it back to Visual Studio this time. And now the first part of the algorithm is done. So choose 10 random bricks. So I'm going to mark this as done. Sure, like that. And then we have to choose one of those bricks out of randomly and then put it down somewhere in the structure. So this is step 1 to choose n random bricks. So I don't need this anymore. Step 2, place randomize brick order and place starting brick. So to randomize the brick order, I'm just going to take the pieces and shuffle it. I think it's in Unity Engine, not random shuffle actually. Alright, maybe one of you know. I'm gonna look it up anyway. Shuffle list C#. Oh, it's in link, isn't it? Using link. Is it system.link? There we go. So now we should be able to do pieces.shuffle. Maybe not. Okay, let's shuffle a string. I thought there was just like a something that shuffle thing. Fisher Yates shuffle, yeah. Usage. Okay, I'm just gonna copy this code. Why not? Yep, let's just do this. Copy this. System.random, system.random. Shuffle. Yeah, why isn't it working? Oh, that's true. Good point, figured. Why isn't... Alright, I'm just gonna do the link way. Order by engine.random. What was the link way, so... Where do I... Oh, that's really... Looks like that. I could have sworn there was a way to do this. And there's not Unity random.next. Random.value? Sure. And to test this real quick, because I don't trust this, just run it a few times. I could have sworn there was one. Maybe I'm just going crazy, but I could have figured that I've seen one before, and I've used one before. I know for a fact I've used one before. It's an ice cream. Let me check my code for ice cream. Oh, too far. Ice cream. How do I do it in ice cream? Oh, I can do that. That's helpful. So how did I do the shuffle? Am I literally just going crazy? I'm actually going crazy right now. I could have sworn. Gosh. Alright. In that case, why did I close that? Dang it. Yeah, I probably did do in my dreams. Shuffle. Or I should do Unity Shuffle. So it should give me. Yeah, fish rates shuffle. It's pretty easy. It says clever way to shuffle it in one line. Let's see. Oh, look at this guy. He just has it already. I'm just gonna take advantage of that. Shuffle. There we go. Thank you, Smooth P on the Unity forums. So now if I come over here, it should be, the array should be shuffled, so let's just make sure of it. Pieces. We do console dot, or no, debug dot log, and then we're going to do piece dot color, or brick color, and we're just going to compare the colors and see if they're in random orders. I'm doing this for my next mod. Okay, so we have 1 0 0 1 1 1 0 1 1 shuffle. It looks like it's working. Alright, that's enough convincing for me to assume it's working. So once again, thank you, Smooth P on the Unity forums. Yeah, I'll send this link in the chat for Figured, just in case you want to take a look at it. So now we can, randomize brick order, and we're going to just choose the starting brick. So brick, starting brick equals pieces dot. Now is there a pop? Remove. Yeah, we're just going to remove 0. Can I not do... Oh, it's probably remove at, isn't it? Well, and it's a void. Okay, so this doesn't work like Java lists. Let's just see what we have options of. Seriously, I need to revamp the code for Nonogram. It's ugly. I'm sure it's not that bad, but if you're saying that you need to revamp it, then it probably is a little messy. I need to go through all my modules as well and just make sure that they're actually cleanish. Insert range. Reverse. Select many. Oh, you know what? I'm doing this the wrong way. Let's just do this. Int current brick equals 0. Pieces current brick. That's easy. Oh no, it's really bad. Alright, let's take a look then. Nonogram. diagram. Assume it's in here somewhere. Diagram module. Oh my, there's a lot. There's a lot of variables here. It doesn't look that bad. Are you making a game? No, I am making a mod for a game called Keep Talking Nobody Explodes. And this mod is going to be a Lego mod. So you're going to have to build a little Lego structure to defuse or not to defuse the bomb, to solve a certain module to help defuse the bomb. Okay, so I picked the starting brick, and I need to place it randomly in the structure. So I'm just, oh, I need to make a structure first. That might be helpful. So we're going to do structure C. Question mark. What does, I have no idea what you were trying to say. C, oh, no, C sharp. Thank you, Pickard. I didn't realize that was what you were asking. It's been a long day. It's only 2 o'clock in the afternoon, and it's been a long day. Equals new structure. Yeah, it is a derp. So the structure, it defaults to allowing height adjustments and defaults to 888. Alright. Perfect. So new structure, and I'm going to do structure dot add brick. Oh, result dot add brick. Starting brick at the position 0, 0, direction in a random direction. So we're going to do random dot range 0 to 4. Okay, where does it using random? Just a few places. Let's come up here. Using random as Unity engine dot random. How did I saw that? Was it there? So this one. C sharp Unity, use Unity engine random by default. How did I do? Okay. Using as C sharp. Marks. Oh, is it equal? There we go. Perfect. Unity engine. Now I should be able to get rid of these. Alright, cool. Sorry, I only did programming in C at school and I forgot it all. I find coding interesting though. Coding is very interesting. It's a lot of fun. C itself is a tough language. I personally hate C, but I'm going to computer science, so I know it. I have to learn it. It's a little confusing. That's why I like using higher up languages like C# and Java. So let's see. If I go through now. Oh yeah, C++ is just a boatload of confusion. C# get nth entry. Oh, is that how you do it? So I can do... So I cast an integer to a direction. And that's how you do it. Maybe not. Java and Kotlin for the win. I'm with you, bud. I am 100% with you. I found procedure stuff easier than object-oriented. I'm assuming that's what you mean. Yeah. It just depends on the person. I find object-oriented a bit easier because of the stuff I can do with it, but there's definitely a place for both. Oh, shoot. There we go. So I added the brick. So now we're done here. So for each other brick, and luckily, I don't need to actually randomize the location of the starting brick. I only need to randomize the direction, because we spent an hour making the add a brick method actually shift the structure over if it needs to. So let's just do this. For int for current brick equals, or current brick is less than piece count, current brick plus plus. Now there's no point. See, this is just going to confuse me later, so I'm going to put this back in here. Say this starts at 1, and then just specify that this is the 0. So now, I have to decide if I'm actually going to do this with goto statements or with for loops, labeled for loops. I'm going to do goto statements for right now, and just see how that works. Ah! Okay. That's what I get for having a bunch of dice on my desk. Organize your stuff. What stuff? Oh, what did I roll? Let's see. That's 4. That's 12. I rolled a 23. So, let's see. Could you make a 1P chess game? Is it hard, or do you need to incorporate the list for the, or incorporate lists for the AI? You could make a one-person chess game pretty easily. It would really just be going through. It depends on how hard you want the AI, because it would just, for the actual board and stuff, you just have a 2D array, obviously, but for the AI, you would need to teach them, and for the user itself, you'd actually have to have a certain, from an object-oriented point of view, which is what I'm used to, you would have a class for each piece specifying how it can move. But from a procedural perspective, you just have to somehow have a data structure, probably in an int array or something, saying how it can move, how each piece can move. And then, depending on how complex you want the AI would either randomly choose one of the possible locations where a piece can move to, or captures, of course, or you can actually have some strategy. And I'm sure you can find a thing online, like some basic strategy for a chess AI, but I've never tried it personally. Probably should. That'd be a pretty interesting project. But I'm sure you can find it plenty online. And if you just search like how to do a chess AI or something. Oh yeah, UI as well. If you want a user interface, that may be a bit tough. Like if you're doing it in Python or something, it's going to be a little harder than it is in Java or C#, but you just have to consider all that. So now we're going to go through each other brick. And Space Sebi, yep. Coding AI is definitely going to be harder than coding the UI. Choose which already placed brick to attach it to. So this is easy, but the thing I have to consider here is if eventually I get down the chain and I can't actually place the brick there, I have to figure out how I can go back and choose which brick to not, or how do I say this? I can't choose that brick again, or else it might just get stuck in an infinite loop. So how I'm going to do this, yeah, and this Christmas music playing, so what? I don't care. I'm not sure why there's Christmas music playing, but there is. So I can do pieces to see which pieces are placed. So what I'm actually going to do as well, I'm going to do public list brick placed pieces. This will first specify the order that they were placed in, but I don't think I really need to record the order that they were placed in, because pieces 11 out of 10. Well, figured if it makes you feel any better, I'm procrastinating on my other work to do this project, so so pieces will record what order the pieces are placed in, so that's not going to be an issue. So I can actually shuffle place pieces all the time. So that's what I'm going to do. So I'm going to do, for each one, I'm going to shuffle the place pieces. Procrastinating and working on your game. What's your game about? Placed pieces that add target brick. I shuffle the place pieces. I'm going to do the... See, this is the point where I need to choose if I do for loops or go-to statements. Can I break out into a certain, let's see, because in Java I know you can do break label, so it breaks a certain for loop instead of just out of all of them. Oop, no, break C#. I'm not sure if you can do that here though. That's the same as follows. Yeah, is it just like Java? Labeled break C#. Alright, if you're pretty sure, I do want to just check. Asymmetric horde shooter where one party plays Left 4 Dead style survival, the other party controls a big horde of AI in an RTS-like fashion. What? The asymmetric horde shooter where one player plays... Oh! Oh, that's kind of cool. That's really cool, actually. I'm really interested to see how that turns out. That's really cool. Sounds cool. I've seen Timmy do it in Battleship. I'm converting some Java code to C# and have found the labeled break statements. C#. Go to jump directly to a label. So it seems like instead of saying break label, I'd say go to label. But you said Tim uses in Java or in Battleship, so I'm just gonna see what he did there. Battleship. Let's see. It's supposed to fix a problem where some of my friends want to play some non-actiony and others want to mindlessly shoot things. Yeah, I feel ya. So let's see if I can find the label somewhere. Set row handler. Set call handler. Just look for colons. So, okay, so retry. So while go to retry, it pops back up here. This is in a while loop. Okay, so I'm assuming it works kind of like Java, but instead of just doing break label, I have to do go to label. So I'm just going to make the safe assumption that that is the case. I mean, it's not a safe assumption, but we'll find out. Okay, so first thing I need to choose is choose a random brick. And brick is less than place pieces dot count. Why is this red? Oh, this needs to be 0. Equals 0. Safe assumption. Oop, auto mod's on. I'm not sure why auto mod's on. And it blocked Pigard's thing, and I tried to allow it through, and then it just denied it. And I clicked deny by accident. Oops. I don't know why that's on. I'm gonna turn that off real quick. Alright, what time is it? It's currently 2:45 here, and I have to be somewhere at 3:15. So, okay, I'm just gonna do this for about another 15 minutes. channel videos. Alright, I just turned automod down, so hopefully it doesn't do that again. I'm not sure why I did in the first place. Let's see. Geometry Wars type game, but augmented. Not sure what that means. Type game, but augmented. Maybe like. Oh, I think I know. Kind of know what you mean. So, you know what? Before I spend too much time doing this, let's actually run a test of how this thing works, how goto statements work. So if I'm going to do a for int I equals 0, I is less than 10, I plus plus, for int j equals 0, j is less than 10, j plus plus. So if j is equal to, let's just say if I is equal to 3 and j is equal to 5, go to, okay, let's call this label 1. If I equals 7 and j equals 2, go to label 2. I have no idea how any of this is going to work, but we're just going to mess with it until I figure it out. If I is equal to 9 and j is equal to 3, go to label 3. Need something after this, don't I? Debug.log. Done. I'm going to do this. So debug.log format I equals 0, j equals 1. So if I run this, let's just see what it says. It should help us figure this out. I think I just made an infinite loop. It's not stopping. It only has 100 things to go through. So why would it be an infinite loop? Oh! You know what? Maybe this is why. Because it's going to label 1 and it's starting the loop over. So I wonder if I can do like continue label 1. No. Okay. So now I have to close down Unity because I crashed it. Unity. Yeah, so the label's gonna have, so the label to just move on is gonna, it can't be outside of the fours altogether. So I wonder what the difference of putting a label here in a label here is. I wonder what the difference between these two is. Alright, once I reopen my Unity, we'll find out. Alright, so let's take a look. So I equals 0, j equals 0, so it wasn't supposed to do anything until I equals 3 and j equals 5. So let's just scroll down to that point. So I equals 3 and j equals 5. It goes to I equals 3, j equals 6. So that makes sense because it jumps to the end of this for loop, which makes it just go to the back to the top. But when I equals 7 and j equals 2, it just jumps straight to 8, 0, which makes sense because it gets out of this for loop and it goes to the next iteration of the I loop. And then at 9, 3, it just stops. Okay, so this is how this works. Got it. Alright, that's not too complicated. So we're going to do... check. Next brick. Let's do next brick option as this label. Next brick as this label. So it's going to choose a brick. Where's my planning sheet? So it's going to choose a brick. And then it's choosing the already placed brick to attach it to. Then we have to choose whether it's going to be on the top or the bottom. Okay. So this is where it starts to get a little complicated because I have to track on which faces it can place it and which ones it can't. Okay. This is going to be a very, very, very inefficient algorithm. But here's my plan right now. Make a list of all options, go through, skip ones you can't do. So it's going to be so terrible for the memory. But that's the only way I can think of doing it right now without having a bunch of tracking stuff. You know what? I have to fix the brick because the brick doesn't know what to do yet. The brick has its faces that it can check, but it doesn't know if the top or the bottom is fully done or whatever. And I also have to see if it... Oh, shoot. I think I just realized something that... I think there's something wrong with my add brick code. I think I just randomly realized that. So the get rectangle thing, if you have a grid like this, let's say it's 4. And there's a brick here. And then you're trying to put a brick here. I think currently it's not going to see these as connected. I don't think it's going to think these two bricks overlap each other. shoot. Because it thinks the bounds... Oh, I don't need this. I need the paint. So it knows the bounds of each one. It knows that it's these... Oh, you can't see that at all. It knows that it's this one. It's an easy code to see. It knows that it's this one, this one, this one, and this one. It knows it's those two. But when I make a rectangle, it starts at this... The rectangle starts here, and it ends here. Right? Because it goes from position 0 to minus dimension 0. Oh, you know what? I think it does work, because this, when we fix this to account for the extra length, because it thought it was the pieces were one bigger, we didn't fix the rectangles. And I think that means it's going to think the rectangle actually goes from here to here. And this rectangle goes from here to here. I think that's what's going to happen. So let me do that test real quick. Alright, I don't need this anymore. I do need this stuff, so... When you comment out comments. So I'm gonna first add a brick. Okay, this structure needs to be 4, 4, 4. I'm gonna add a brick that is at 1, 1. That is 3 by 1. One, 0. And I'm going to add this brick to 0, 0. That's 2, 2. Hopefully it sees that these collide. Cannot place brick there, collision. Perfect. But if I go back here and go into the north code, because rectangles are defined by width and height. Oh, wait a second. Now it's just confusing. So, well, it's not confusing. I think that's actually working as intended. Unintentionally working as intended. Because it knows the width is 2. So from this corner, so 1, 2. Yeah. Oh. Alright, I'm freaking out over nothing. It works. What was I doing before that? I don't remember. You know what? I've been working on this for 2 hours now. And I need to go soon. So this is what I'm going to do. I'm just going to go take some Advil because I have a little headache. And I may or may not stream later today. May or may not stream tomorrow. But on Monday I definitely should. Yeah, I think so. Yeah. Well, I'm going to head off for right now. Thank everyone for watching. Oh, real quick though. I do have a terrible, terrible, terrible webcam. Would you guys prefer to have that on or off? Because, I mean, it doesn't bother me either way. But it's really, really crappy quality. I don't know. Up to you guys, I don't really care. But I'm going to head off for right now. Thanks everyone for watching. So one of you say on, one of you say maybe, and we'll see what happens. Thank you everyone. Goodbye.